everyone. Hi, I'm super excited to be here. Thank you guys all for coming out despite the weather. Really excited to have you all here. My name is Tess Grindlay. I am an undergraduate student at the University of Victoria, entering my final year of studying physics and astronomy. And throughout my degree, I've done a few different co-op terms, or work terms as they're also known as, where I've explored kind of different areas of astronomy. And one that I really kind of brought me to talking about this today is a co-op term I did at the Canadian Space Agency, where I was a part of the space astronomy missions team helping to organize the first round of Canadian science experiments on the James Webb Space Telescope. So through that co-op term, besides learning about the James Webb Space Telescope, I also learned about some of the other really exciting space missions being planned and executed by space agencies all over the world. And this is kind of one of the ones I'm talking about today, one that ever since I've heard about it, I've been super excited to see where it goes, and actually has a brand new kind of breaking news update in the last week. So I'm really excited to be presenting that kind of a big overview of the Europa Clipper mission, which is, I'm very excited to be talking about this today. So yeah, we were talking about the Europa Clipper mission and how it's gonna be helping us learn and understand a lot more about the secret ocean world that is Europa. Okie dokie, so to begin, I wanted to give kind of some big background ideas here about the Jupiter system. So when I say Jupiter system, that's referring to Jupiter and its associated moons and objects that orbit it. So Jupiter is, again, the largest planet in our solar system. It's really massive. It has a lot of gravitational pull, so it's able to pull in a lot of different objects. And so Jupiter has 95 recognized moons, but of those 95, a lot of them are quite small. There are 4 major moons that are considered significantly larger than the rest of all the objects that orbit Jupiter, and those are Io, Europa, Ganymede, and Callisto, which are seen there. And they all look a little bit different than one another. So Ganymede is the biggest of Jupiter's major moons. It's actually the biggest moon we have in the solar system. It's bigger than Mercury. And then we have Europa, which is kind of the major moons, the smallest. And that's the one we'll be talking about today. So focusing on Europa here, it's the smallest of Jupiter's major moons. It's actually slightly smaller than our moon, 90% the size of our moon. And initially, from kind of ground observations, really not much detail could be seen. You know, like, it kind of just seemed like this pale reflective dot. That image I'm showing up there is from Pioneer 10 mission, which in 1973 was the first space telescope to observe the moon of Europa. And we can see in that image there's not a whole lot of detail, right? It passed by Europa at 300,000 kilometers away, and this was the best image it got. We can see there's areas that are lighter and darker, but besides that, really no detail that is standing out quite yet. And then a little bit later, in the 1970s, the 2 Voyager missions were launched by NASA. You may have heard about the Voyager missions. These are probes that were sent out to hopefully go as deep into space as we could. And on its way out, they passed by Europa, both at different distances, and they took these different images. So we have Voyager 1, which passed by Europa at 2 million kilometers away, and was able to get this picture, where we start to see a little bit more detail here. We see these lighter and darker spots, as well as we start to see these lines across its surface, which are very interesting and have become this key feature of Europa. And we later saw those in a lot more detail when Voyager 2 passed by Europa in 1979 and got to see, again, those large line features all over its surface. Were really exciting to scientists. You know, that was kind of what could be causing this, what's the mechanism that's making these images like this, these shapes appear. But there's another really important observation that was taken with this Voyager 2 images, and that's a surprising lack of crater impacts, like lack of craters on the surface. So scientists know kind of the expected amount of meteor or asteroid or just general impacts that should happen in a planet's life. And looking at Europa, it did still have some impact craters, as you can see on the image, but it had a lot less than the other icy moons in the area, which was an interesting observation because that means something on the surface is changing or renewing itself. There's some mechanism there that's creating, as they call it, a geologic world with an actively changing surface, which is really exciting. So that kind of became this area of interest. And then later on in the later 90s, the Galileo mission revealed the highest quality up-close imaging we have of Europa to this day. We can see those line details have been strengthened and kind of are such a main focal point of this image. We see there's some that go in kind of long distances, some that are crossing over others and kind of look like kind of chaotic, which was a really interesting observation. Those lines, their reddish color is actually coming from a higher concentration of salts, which is a very interesting thing to observe. And the Galileo spacecraft also made a very, very key discovery about Europa, which was the existence of a subsurface liquid ocean. But how could we possibly detect this? You know, we can't see the ocean in these pictures. Does anyone have any ideas on how they could have detected this without actually seeing the ocean? Okie dokie. So essentially on Galileo, there is an instrument called the magnetometer, where it's measuring the magnetic field as it travels, as it does this, these observations. And while it's measuring the magnetic field, you know, it expected some readings because Europa is very close to Jupiter, and Jupiter has a very huge, significant magnetic field. But while it was traveling around, it actually noticed there was an extra induced magnetic field around Europa itself. So something within Europa was actually taking in this incoming magnetic field from Jupiter, distorting it, amplifying it, and creating an induced magnetic field around Europa, which is very interesting and suggests the presence of an electrically conductive layer that's able to move and create this sort of induced magnetic field around Europa. And scientists believe that comes from a subsurface saltwater ocean, where that salt is what's making it conductive. And then that would also explain the presence of those reddish salt lines all over the surface, because that could be from the presence of salt water rising up and then freezing on the surface where it has this higher concentration of salts than the rest of the surface. So it kind of started to answer some of these questions about Europa, but also left us with a lot more questions. Okay, so here's a schematic that kind of summarizes what we know and theorize about Europa today going into future missions. So I'll first want to focus on the interior. So it's known as the core and the mantle, what we think we know about Europa's interior. So Europa is thought to have a metallic and rocky core, a metallic and rocky interior, where the core is made of iron and nickel and metallic, and then the mantle is rocky, very similar to Earth. We found this out using gravitational field measurements from the Galileo mission I mentioned previously. And then also one really important observation about Europa is that its orbit around Jupiter is not a perfect circle, right? So that means at different points around Jupiter, it's experiencing a different amount of gravitational force from Jupiter, a pulling on it from Jupiter. So as that force changes, it causes this kind of repetitive friction in the interior of Europa, because it's like pushing and pulling and tugging at different intensities. So when that happens, it creates this thing called tidal heating, where this friction is causing material to rub against each other and generate heat, like kind of when you rub your hands together and you get warmth. That sort of same effect of material rubbing against material with friction. And that's what could keep this subsurface ocean warm enough to stay liquid, even at this far distance away from the sun, is the presence of this tidal heating force. Okie dokie, now I want to talk about Europa's surface, which I've shown a lot of pictures of, and I'm going to show another one. These are some really cool pictures, all taken by Galileo, the probe, not the person, where it's showing all the, kind of a summary of some of the really distinct features that have been studied and classified by astronomers, geologists, and planetary scientists. So I wanted to point out a few kind of key ones that kind of draw my eye and kind of make me ask these questions about how they could form. So we have, again, those ridges or lineaments, bands, kind of different names for those long lines across its surface. Maybe caused by, again, water rising up through cracks in the ice shell, which could, the cracking in the ice shell could be coming from that tidal heating, pushing and pulling force on Europa. Through that process, there could be cracks in the ice shell, kind of like cracks in an eggshell, and then water is able to come up through that and freeze, or the actual ice shell starts to crumble. There's also this chaos terrain here, where it seems like all different surfaces and colors and textures almost, and that could be coming from icy terrain being broken up and crumbling, and then water rising up and then freezing as well. And there's a couple different examples, again, of ice changing, forming these knobs and pits as well, so raised sections and also, you know, pits of lower sections. And then there is also still impact craters on Europa. Again, we notice there's less of them because of this changing surface, but there are still definitely some noticeable impact craters that exist on Europa today. Okay, finally, I want to talk about our understanding of the ocean layer and the major questions that remain since we've figured out that there's probably an ocean there. What could that ocean look like, right? So we estimate that on Europa, it has 2 times as much water as all of Earth's oceans. But there's a lot of important questions that remain. You know, like we haven't obviously been able to observe this directly. So there's lots of questions we have. For example, the ice shell, right? We estimate the thickness of the ice shell is approximately 15 to 25 kilometers, like globally, like an average. But you know, is that the same everywhere? You know, for reference, the thickest ice shell on Earth is 5 kilometers. So this is a very, very thick ice shell. But is there sections where there's, you know, gaps, kind of like in this image here? We see there's some spots where there is liquid water kind of stored in the ice shell. Is it cohesive? Is there these pockets? Is there thinner spaces? There's also lots of questions about exchange between the ocean and the surface and the ice, and if there's an exchange of material, right? We've seen some evidence of geysers occurring on the surface of Europa. That's another one of the main things we want to be looking for going into the future, is finding direct observations of these geysers that could be exchanging material from the ocean onto the surface, as well as the existence of hydrothermal vents, kind of like we have on Earth, these hydrothermal vents that could come from, you know, warmer spots. With that tidal heating, there could be inconsistent spots where there's spots that are warmer and generating a warmer ocean there, which could again cause ocean currents to exist. So there's lots of questions about, you know, what this ocean could actually look like. Okie dokie. Okay, so with what we currently know about Europa, scientists believe it could be habitable. So when I say habitable, this is a term astrobiologists use, so people that study what life could look like on other planets. They call something habitable when it meets these criterias for life. What we currently believe are the 3 main criteria for life to exist possibly on a planet is first liquid water. You know, liquid water on Earth acts as a solvent for lots of different chemical reactions. And we know that Europa has the presence of a liquid saltwater ocean, most likely. There's also the existence of bioessential elements, so things like carbon, hydrogen, nitrogen, oxygen, and phosphorus, and sulfur. Those work together to form organic molecules, which are fundamental to us and other forms of life existing. And these elements are theorized to exist within Europa's ice shell, or even be originating from its rocky core, and then possibly could be accessible within the ocean over time, could be accessible in there. And then finally, all life forms need sources of energy. Like for us, it's eating food. For plants, it's using the sunlight. And we do have, you know, life forms on Earth that exist just off the energy from hydrothermal vents or from living in an ocean deep away from the sunlight. We have life that can survive in conditions like that. So the tidal heating on Europa could be a viable energy source for life to exist on Europa. So to understand and answer these questions about if Europa could be habitable, we have to go back to Europa. We have to do a Europa-focused mission. Because again, all the previous missions have been either going out into deep space or studying the Jupiter system and just doing some close flybys of Europa while it's there. We want a Europa-focused mission. So this sort of mission has been in the works for decades. We see a couple kind of mission concepts that never made it off the ground, literally. We see a few different versions of ideas, and they all have different shapes and sizes, and some, you know, have technology that wasn't explored or have some very interesting ideas. But yeah, we ended up with this finalized Europa Clipper model, Europa Clipper mission idea in 2015. And I'll be introducing you to the Europa Clipper now. So the Europa Clipper is a mission that just recently launched as of this week. This is the breaking exciting news. It launched on October 14th. And is planning to arrive in the Jupiter system in April 2030. So it has a long journey ahead of it, but it's excitingly well on its way. And it's an orbiter probe, so it's not landing on Europa, but it's doing a series of close flybys to Europa's surface. And when it gets to Europa, it will be investigating Europa's habitability. That's the goal of its mission. And to do that, it's going to be exploring Europa's ice shell and ocean, its composition, and its geology. So here's some quick statistics about the Europa Clipper. So it spans over 30 meters. It's about with its solar panels fully extended. It is the size of a basketball court, as we see there, and it weighs over 7,000 pounds without fuel added to the system. With these massive solar arrays and these radar lines as well, it is the biggest mission NASA has ever created and developed for a planetary mission. It's the biggest craft ever developed for a planetary mission. It's got this core region here that is 3 meters by 1.5 meters. I have some images there of the scientists at NASA and JPL putting together these instruments. I always like having humans for scale to see what they're working on. But yeah, so this is a really exciting mission. Oh, sorry. Next, we're going to talk about the instrumentation on board. So within that core region I just showed, there's 10 instruments contained in there. These 10 instruments kind of focus on all measuring different things, but all coming together again to plan to gather the data to execute the mission goal of studying the ice shell and ocean, the chemistry, and the geology. So in this we have, this is supposed to play, there we go. So in this video and in this image we can see that there's 10 instruments. 5 of them are considered remote sensing instruments and 5 are in situ instruments. So when I say that, remote sensing means I'm looking at something far away. I'm looking at, I'm looking at Europa from a distance and I'm taking a picture or doing a measurement from far away. An in situ instrument measures the space that it's presently in. So it's taking in data or actual dust particles and measuring them from that it's directly surrounded by. So that's kind of how we classify the different instrumentation on board. It's separated out into these 2 types. Okay, so this is an explanation of all the remote sensing instruments on board. So we've got 4 different imagers. We have our Europa imaging system, which has a wide angle camera and a narrow angle camera. These are higher resolution and a lot more detailed than we've ever seen with a Europa-based mission. Like with the Galileo images I showed, those had a best possible resolution of 6 meters per pixel in image. The Europa imaging system, I think, operates at around 0.5 meters per pixel, so you're seeing way more detail in these pictures. We also have some spectrometers, which essentially measure compositional data. They all focus on different things, so one of them is looking at identifying different salts and organic compounds, maybe on the surface, and then the other one is more focused on looking at the atmosphere and the different elements that exist within the atmosphere of Europa. And then we also have a thermal camera, so kind of like a thermal camera that shows different temperatures. That could be used to find the hot and cold regions I was talking about before from this inconsistent tidal heating. And then we also have a radar system on board, so it's ice penetrating radar that will help us understand different properties and characteristics of the ocean underneath, like the depth, what the ground, like the ocean floor could look like, details like that, which is exciting. And then we have our in situ instruments, 2 of which are focused on chemical analysis. So we have a mass spectrometer that measures the gases that it's currently flying in to hopefully measure the composition of Europa's atmosphere. We also have a dust analyzer that looks at the composition of any sort of surface material that could be kicked up from Europa. It wants to try to measure that exact compositional data as it flies by. And then we have 2 instruments looking again at the plasma and magnetic field. Like we mentioned before, the magnetic field helps us understand details about the ocean and just the general environment that Europa rests in. So it's going to be measuring the magnetic field as it circles around Jupiter. And then we also have our gravity and radio science experiment, which will be measuring the gravity throughout Europa's orbit. Okay, so now I get to talk about, again, the breaking kind of exciting details that have just come out recently. So the Europa Clipper launched successfully from Cape Canaveral at 9:06 a.m. on October 14th. It was supposed to launch October 10th, but I don't know if anyone remembers anything happening in Florida on October 10th. There was unfortunately a hurricane, so not the best conditions to launch in. They were able to keep all the technology safe during the hurricane and launch successfully on October 14th. They used the Falcon Heavy rocket by SpaceX, which was one of the only rockets with enough strength and energy to carry this very large probe. And the launch was a multi-stage launch. It had multiple different separations where first the boosters came off, and there was some major fuel burns as well to get into the correct orbital position. We have here some pictures of the different stages of the launch. We have this image of it sitting all ready to go. We have a beautiful picture mid-launch. And then we have the final picture we have of Europa, the Europa Clipper, as it floats away from the rest of the rocket as it's been launched out into space. This is just a diagram showing the ascent timeline, how it launches and then loses those boosters, separates from that main stage, and then flies the rest of the way, does some burns to get into the correct position, and then also loses those fairings, so the protective things around the Europa Clipper probe itself also So this is kind of an overview of what that launch was like. And so now the journey that the Europa Clipper has ahead of it is a long one. It will take 5.5 years to get to the Jupiter system. This process includes 2 different gravity assist maneuvers with Mars and Earth. So in that process, essentially a gravity assist maneuver is when a probe or a spacecraft flies really close to another planet and then gains velocity and also can be, I guess its orbit and trajectory can be adjusted using the gravitational force of the object it flies close by. So we can see in that image here, it's in green. Yeah, and then once it arrives at the Jupiter system, the Jupiter orbital insertion is performed, where the engines are started up once again to help slow down the probe to reach the same speed that Jupiter is moving with. And then also it does another gravity assist with Ganymede to help kind of reshape the orbit to end up properly in the Jupiter system. So once it arrives in the Jupiter system, like I was talking about, it will perform a total of 49 flybys of Europa. This involves actually, it's not orbiting Europa directly, it's orbiting Jupiter, and then every so often it will dip in close to the Europa surface, take data, and then kind of fly back out. We can see Jupiter is the green dot here, and the Europa Clipper is the pink line moving. And we can see that it's in the Europa, the moon is the blue circle. So you can see it's kind of moving quite far away at times, and that's because the environment around Europa within that close by Jupiter is full of radiation. It's a bit of like a dangerous environment to be in with technology. So what it does is it dips in close, collects all the data it can, and then once it's farther out, then it's able to transmit the data back to Earth safely. Yeah, and we can see here this map of kind of the different close flybys we'll be doing, categorized by the distance from the surface that it will be going, get as much as a cohesive coverage of the surface that they can. Okay, now I'm going to talk about some exciting things that NASA has put on to engage with the public and get people really excited about the Europa Clipper mission and what this could mean for space exploration in the future. So it's kind of a tradition in NASA to write, inspirational messages or descriptions about humanity on deep space missions and space missions in general, like with the iconic Voyager records, or just inspirational messages written on Mars rovers. So in the case of the Europa Clipper, they decided to put some art pieces on the vault plate. So the vault plate is protecting a lot of those electronics from the intense radiation that it's experiencing within the Jupiter system. So the outward side, we can see kind of where it sits in that main body of the Europa Clipper, and we can see this art piece here that they've done called Water Worlds, where essentially, as you can see in the closer up zoom-in image, contains multiple waveforms of people saying the word for water in their spoken language. So it's 103 different spoken languages where they've been chosen to have their word for water kind of like just kind of a summary of humanity's idea of water and this connecting feature between us and what we think we know about Europa to have this liquid water ocean. It's kind of this uniting factor. So a lot of the pieces on this public engagement vault plate kind of focus on water and what that means to us and what that could mean for another celestial body. So on the other side, on the inward facing side of the vault plate, there's some important information and kind of things to honor the beginning of the astrobiology fields. So there's this inscription of the Drake equation, which is a really famous equation in astrobiology that represents the probability and chances of finding intelligent life in another area of, like, another body in the solar system. So it's a series of variables that kind of, are measuring out the chances of there being an intelligent life group out there that we're able to contact. It's a few different variables about that. And then there's also a image, like a portrait of Ron Grindlay, who is a fundamental researcher in planetary science, who was one of those first people back in the 90s to start focusing on a Europa-focused mission. And then there's a couple more things I want to talk about with the vault plate. So there's also a large block of text on the vault plate, and that's actually a poem written by a Nobel laureate named Ada Limon, who wrote a poem kind of focused on this uniting factor between us and the Europa moon about water, kind of how that connects us. So she wrote this poem in praise of mystery, and I have an excerpt of it there that kind of again talks about this uniting factor and how we're going to Europa to try to learn more about how life can exist in other places. And then finally, NASA put on a message in a bottle campaign where essentially it invited the public to submit their names to be put onto the Europa Clipper. So they essentially took the 2.6 billion names that were submitted and then wrote them on this tiny little microchip like the size of a fingernail, and then put it in the middle of this message in a bottle sort of art piece there about the Jupiter system. And excitingly, my name is also on that, which is exciting. So my name is on its way to the Jupiter system right now. I don't know if anyone else in here has also submitted their names, but if you have, we are on our way to Jupiter together. Yeah, so now I'm going to talk about just a few final points about what we can expect during the Europa Clipper's journey and what to expect when it gets there. So it's supposed to arrive in the Jupiter system in April 2030 and then begin science operations in May 2031. So when it arrives, after performing a series of maneuvers to get into the right orbital position, it will take us to May 2031, where it will begin looking at Europa's surface, its ice shell, its ocean, its composition, and its geology. At the same sort of time, the European Space Agency's Jupiter Icy Moons Explorer, or the JUICE mission, will arrive in the Jupiter system in 2031, which is exciting for scientists because now we are going to have two different data points studying kind of similar things in the Jupiter system at the same time. We'll be able to kind of get a better understanding of Jupiter's entire magnetic field and gravitational field and how the different moons of Jupiter are affected by that. So that's exciting. I have an image of the JUICE mission there. And then also mission plans currently, it's sad to talk about the end of the Europa Clipper, but currently the plan to deorbit the mission and end the mission is to crash it into Ganymede surface in 2034. And this is a common practice in astronomy. We don't really want to leave probes or things orbiters if we don't have to leave them. They can, cause issues in the future. So sometimes, in the past we've ended missions' lives by sending them into Jupiter. In this case, they're planning Ganymede, but that is something that I think is subject to change depending on if they extend the mission is also a possibility. Lots of NASA missions get extended if all the technology is still working correctly. So that could be up in the air, that could change. And then with the Europa Clipper data, one of the main kind of secondary goals is to kind of scout out possible locations for a possible future Europa Clipper lander. If we wanted to land something on the surface and maybe even try to test the ocean and do measurements there, the Europa Clipper will get some really important data to find these safe places to land. Yeah, so that's everything I wanted to kind of introduce you to with the Europa Clipper today. I really hope everyone stays tuned and keeps their ears open for when news of the Europa Clipper's arrival at Jupiter and important science starts to come out as we learn about its interior, geology, and chemistry. Thank you guys so much for being here. If anyone has any questions.
Oh, I get the microphone. Okay, excellent. You are on your being live streamed. Gotcha. Thank you. I am wondering. So you said it's going to arrive in its correct orbital position in May 2031. Yes. So how long are we expecting it to take to start sending observations back to Earth? Like immediately, or is it going to take a couple months, or what's up with that?
So to my understanding, the science operations begin in May 2031. So that includes getting into the right orbital position before that, as well as like testing instrumentation, I believe would be occurring before 2031. Well, that specific like start of operations. I think we could start seeing results. Like hopefully they will be publicizing a lot of the data. I know at some point the data is also being planned on like released publicly, like just the raw data. But I'm not sure the exact timeline on that. But I know that usually with space missions, the people who have proposed specific, science goals get access to that data first, are able to analyze their results, and then publicize it, and then that goes more public for people to use and play around with and see what the results they can get. Yeah, I hope that answers your question.
Anybody else? Oh, come on. Yes, go ahead.
The launch of the mission from Cape Canaveral had that SpaceX grabber just as a side point from the launch of it. If anyone remembers that when I think the booster was collected again, that was interesting.
So yeah, with this, these boosters with the Falcon Heavy rocket, those boosters have actually flown 6 times before the Europa Clipper launch. So those boosters have been retrieved and flown again. Unfortunately, the Europa launch was actually the first time they were not retrieved, and that was planned. Essentially, the path and the amount of fuel that was needed to get the Europa Clipper in the exact position it needed to be in to be on the correct path for its later orbital maneuvers used up the booster's energy as much like to the end of it, so they didn't have enough of fuel left to arrive it back and like land it properly. So those unfortunately were not probably going to be able to fly again. I'm not sure if if they were retrieved or if they were burned up in the atmosphere. But yes, they have flown and they do have that ability to come back, but they didn't end up using it for this mission.
Yes, I believe that was another. It was another one that was flown like just like right, really close. It was another one to do. Yeah. Okay. Anybody? There was somebody else. Oh, Kirsten.
Just curious if there's any knowledge today about how deep the ocean or suspected ocean is on Europa. And then just a second question, with respect to the orbiter, is there any chance that it would be able to detect organic life if it exists, or are we basically going to have to wait until something actually lands on the surface?
Thank you. Yeah, that's a really great question. So for the first part of the question, sorry, I'm going to answer the second one first because I had a thought of that one immediately. So with actually detecting life itself, the surface of Europa is pretty intensive an environment for life to be in. You know, it's experiencing this intense radiation and coldness from just the presence of, like, the existence of where it is. So I think, you know, the Europa Clipper mission is not intended to detect life directly. It's more trying to, like, diagnose if it would be considered a habitable, you know, candidate for life to exist later. I don't think they're planning, like, expecting to detect life directly with the Europa Clipper mission, but it would be very exciting if they did. But I don't believe that's one of the main ones. And maybe on the dot, yeah, it could. You know, there is lots of ideas about how there could be, you know, surface ocean water exchange. You know, with those geysers, that's a main, like, one of the main kind of interesting points is that they're really hoping that they happen to be passing by when there's a geyser, and they, like, ideally they could fly directly through the geyser. Is I think, you know, there's room for, you know, last minute adjustments and room for, like, if something comes up to adjust the mission. I believe that's one of the kind of goals with that. And then I'm blanking on the first part of the question again. Do you? How deep? Oh, how deep? Yes. Sorry about that. I don't know the number off the top of my head. I think they have, again, to make that estimate of, like, the 2 times Earth's amount of water, I think they have, like, a kind of, again, a global estimate sort of with the ice sheet. I unfortunately don't know that number off the top of my head, but that is a really great question. Yeah, and I think NASA currently has lots of really great information about Europa because it's such, like, a current topic. So I think there's definitely some places we can find that out.
Yeah. Anyone else? Could I ask you to go back to where you were doing that the laps around? Yeah. That was fascinating. Absolutely. Yeah. Okay. Is this? Oh, yes. This is how far away from this one is how far away it is all the time. Like, it's going from like, sometimes it's 3 and sometimes it's 2 million and sometimes it's 3 million. Like, is that how far away it is? Okay.
But I could definitely check on that and get back to you on that exact detail. I wouldn't want to say, like, I wouldn't want to guess, but I'm not entirely sure.
But then you just said that it might actually be able to fly into, like, or above, or something, like one of the geysers. So it can't be 1 million kilometers away from there. I mean, it's got to be. Oh, okay. Then you're okay. That's what they're doing. Yeah. Yeah, so I was just going to ask how far up are they going to be? You know, that would be good. Okay.
I think they want to get quite close.
Mm-hmm.
So I don't know if it's, like, the minimum flyover. I think, or actually, like, there's some regions that it's hoping to be, like, within 0 to 50
Oh, gosh. Okay, right. I missed that. Okay. Is there anybody else that has another question? Oh, yes.
Has there been any other discoveries of moons with possible life except for Europa?
Okie dokie, thank you. That's a really great question. I do believe there's some other moons that have like ideas to be have a subsurface ocean. We haven't had confirmation of life or anything existing in these subsurface oceans. You know, they are like a prime candidate for something sort of, maybe there's a lot of parallels to Earth's ocean when it's at these like very cold, dark, far depths in our ocean. Like we have questions about what that looks like on our planet, you know, so there's lots of parallels to be drawn with I don't know the number off the top of my head of the exact number of moons that we think could have this. I believe there is at least one other one. But yeah, they haven't been able to detect life or anything directly on those, but maybe in the future.
I have one more thing that I'd like to ask you, and that is, are you going to be able to continue to do some work on this, or do you have to, you know, kind of, unfortunately, kind of move on to something else, or like, what are your, what's in the future for you?
That's a really exciting question. So yeah, researching the Europa Clipper was kind of just a passion project for me. I haven't worked directly on the Europa Clipper mission. That would be such a dream to be involved in some way. Like previous research work I've done has been more focused on like extragalactic, like work on galaxies. But I do have a special place in my heart for planetary science because I think there's a different, like they kind of appeal to different sides of myself. Like one is so far away and so different than what we know, and planetary science you can find a lot of like similarities to where we are. So, you know, I would love to do work on this in the future, but I guess we'll see. Yeah.
Well, thank you very much, Tess, for coming again, doing this, and she's just really outside of the forum. But thank you so much for coming.
Thank you.
Our future is bright.
Thank you so much.